Hey my friend, it's Joey. We'll look into coding a Python program to check Armstrong number. It's going to be an exciting video, thus you should watch this video till the end. Let's quickly look into what an Armstrong number is. Take a look at this number 370. It is an Armstrong number of order 3. How? If you sum up the cubes of 3, 7 and 0, which are 27, 343 and 0, then the sum comes out as 370. Which is equal to the number itself. This equation proves that 370 is an Armstrong number. Why summed up the cubes? Because 370 is an Armstrong number of order 3. Now take a look at this number 1634. This is an Armstrong number of order 4 because there are 4 digits in 1634. So the summation of 1 to the power 4, 6 to the power 4, 3 to the power 4 and 4 to the power 4 should be 1634. Interestingly, it is. 1 to the power 4 is 1, 6 to the power 4 is 1296, 3 to the power 4 is 81 and 4 to the power 4 is 256. When we add them up, we get 1634. So this is the check we need to do in order to determine if a number is Armstrong number or not. Let's go straight to PyCharm now and start coding the program. So this is my PyCharm IDE in which within this script I am going to write this program to check the Armstrong number. If you don't have PyCharm installed on your machine, then you can watch this video in the I button. And if you're new to my channel, then do hit the subscribe button and hit the bell icon because that way you don't miss out on any of the videos I make on Python programming. We'll begin with writing the main function first. So let's write the main keyword and we have it already. Now we'll take the input from the console for which we'll use a variable n, and after the equals to sign we are going to make use of the input function within which we'll pass this message, enter the number to check. Alright, so this input function will be used to take the number that we need to check from the console, and it's going to store that number in this variable n. Now we are interested in knowing the order of the number entered. This order is basically the number of digits we have in the entered number. And how can we find it? Using the len function, which gives us the length of the entered input. So we'll write v_order, the variable that is going to store the length of the entered number, and after the equals to sign we'll write len, and within its brackets we'll pass n. So this is going to find out the order of the number entered. Also we'll assign the value of n to a different variable, let's say vnum. We'll typecast it to an integer because the value that we receive from the input function here is a string. That's why we need to typecast it. The next step will be to start a for loop that starts from 1 and goes to the value that is stored in the order variable. So for that we'll write for I in range 1, v order plus 1. Alright, so if we enter the number 370, then the order will be 3. This loop will run 3 times then. Okay, now we'll find the remainder by dividing the number stored in v_num by 10. So let's write the code for that. Rem will be the variable that is going to store the remainder. After the equals to sign, we'll write v_num modulo operator 10. Alright. For the remainder that we are going to get, we need to find the value by raising this remainder to the power of the value stored in the order variable. So if the entered number is 153, then dividing it by 10, we get the remainder 3. We'll get the value as 27 as a result of the remainder 3 raised to the power of 3, which is stored in v_order. So let's write the code for that. We'll use the pow function and add it back to the variable sum that we'll initialize to 0 over here. So let's first declare and initialize v_sum over here to 0. And then we are going to write over here v underscore sum plus equals to pop rem comma v underscore order. There you go. Now this variable v underscore num will have a new value which will be obtained by dividing it by 10 and storing the quotient. So let's write the code for that. It will be v underscore num equals to v underscore num divided by 10. So going ahead with this example of 153, the value stored in v underscore num will be 15 now. 153 divided by 10 is 15. The quotient we are storing in v underscore num. So v underscore num will now contain, after the first iteration of the for loop, the value 15. This process will be repeated in the next cycle of the for loop. So now in the next cycle, v underscore num will be 15. The remainder will come out as 5. 5 raised to the power of 3 is 125, which will be added to the value stored in v underscore sum, which is 27 from the previous iteration. 125 and 27 becomes 152. So in the second iteration, v underscore sum becomes 152, and the value that gets stored in v underscore num is 1, because 15 divided by 10, the quotient is going to come out as 1. Alright, so I have explained all the calculation to you. After this loop, we'll write an if else which will compare this v underscore sum variable with the value stored in n. If they are equal, the value stored in n will be declared as an Armstrong number, otherwise no. Let's write the code then. So we'll write if v underscore sum equals to sign int, because we need to typecast to n again. If they are equal, then we are going to print curly braces is an Armstrong number, and within format we are going to pass n. Alright, if they are not equal, then we are going to simply print value stored in n is not an Armstrong number. Alright, so our program is complete. Let's run it and check the output. Alright, it is asking me to enter a number to check. I'm going to enter 153, which I know is an Armstrong number. Okay, the program says that 153 is not an Armstrong number. I deliberately made a mistake over here, which most of the programmers make. Let me tell you what that mistake is. Over here in this line of code, I have divided v underscore num by 10. What it is doing, it's storing a float value inside v underscore num. We need to store only integer quotient in v underscore num. Rather, it is actually dividing v underscore num by 10. So let's say 15 is divided by 10, then Python is storing 1.5 in v underscore num, which we don't want. We want 1 to be stored in v underscore num. So we need to typecast this calculation to integer, and then everything will be all right. Let's run the program and check again. Okay, so it is asking me to enter the number again. I'm going to enter 153. There you go. Now it says 153 is an Armstrong number. Let's check another number. So let me rerun this program. I am going to enter 370 this time, and let's see if the program considers it as an Armstrong number or not. Okay, the program says that 370 is an Armstrong number too. Let's check 1634. Go over here, I enter 1634, and it recognizes 1634 as an Armstrong number as well. Let's put some other number which is not an Armstrong number to check a negative test case. Alright, so let me enter 12. This is not an Armstrong number, and the program says so too. Let me enter another number. let's say 125. All right, so the program correctly says that 125 is not an Armstrong number. With this, we have come to the end of this video. I hope you enjoyed watching this video. Do give this video a thumbs up, share it with your friends and colleagues. I'll see you in the next video of Joy's Tech. Goodbye and take very good care of yourself.